Okay, so welcome everyone one more time. I think we can start with the next presentation, Advanced Mixed Reality. Goran, it's your time. Thank you.
Hi, everyone. I'm Goran Adrinek from Croteam, and welcome to my talk about mixed reality in serious MVR games. So before I begin, I'd like to know who I'm talking to, so just a few hand-raising questions. Has anyone here tried mixed reality, like gaming or other experience here? Raise your hand. Really? I mean, virtual reality. Okay. So, not many virtual reality players here. Okay, so this talk hopefully introduces you to the topic of virtual reality also. So, I should probably explain what mixed reality is before I start. So, we have virtual reality, you know about that, and when I started doing mixed reality, I didn't really know what I'm supposed to do. So I think I've seen this video. It's actually a promotional video for the HTC Vive that shows some mixed realities. So I'm going to skip the rest. It can take a while. So from this video I learned, oh, so that's mixed reality. So you're supposed to mix real world stuff with the virtual stuff and produce some kind of cool videos. So this looks complicated. So I was like, whoa, how do we do this? I'll get down to that. And why do we even need mixed reality for? Well, promotion. Since I noticed not many VR players here, we try to reach out to the audience to show them what virtual reality is, what our game looks like. And as you've seen in the previous videos, you can see people inside the game playing with stuff and doing that. So we wanted to do that for our own game. That was Serious Sam VR, The Less Hope, that we shipped in early access last year, and it's still in early access, but it's going to come out soon. And here's a little trailer we did with that game to show the game.
Looks to me like things just got seriously real. Oh yeah.
I'm sorry about the technical.
Whoa!
So here in this video, there are several approaches to showing how the game looks like to the player outside of VR. At the start, you could see some floating guns and stuff. I think it looks a bit weird. By the middle of the video, you can see an actual guy holding guns and shooting at stuff. It kind of looks like he's in the game, like stuff is happening around him. So we try to describe this feeling of virtual reality, how it looks like with those mixed reality videos. And this all started for us when we were doing promotion for our game that was about to ship. It was supposed to be showcased at the Eurogamer Expo last year, but yeah, last quarter I think it was. So we were supposed to be featured on the HTC Vive stand there, And we had a nice little toy. There is like a physical minigun you hold in your hand and you play the game with it. And it looks cool, it spins, and you really hold the same gun you see in virtual reality. And we also wanted to show that in mixed reality, how it looks like, to look even cooler. So when it started, it was like, so what are we supposed to do with this? How do we do it? We read some articles, and HTC people told us, well, you know, we did this with other games, mostly Unity games. They have this plugin that gives you some multiple views of the game that you can afterwards mix in some kind of software. You mix several views, the player, and put it all together. Some problems? Anyway, we have an... okay. Hi. So we have our own engine and our own tech, and doing that, yeah, we simply had to implement the stuff they used in Unity, for example, and show those views so they can grab it by that software and mix it all together in a mixed reality video. And we started doing that, and we foresaw some problems, expected the problems with, of course, performance, because we do several more views. Yes, it happened on my last talk also. Thank you, Windows. I'm so happy. Okay. And I also expected some sorting issues, because you don't know what, it's hard to draw a line, as said, what's in front of the player, what's behind, because things can always intersect. And player wouldn't quite feel like he's inside a game, because there will be in-game lighting, and projectiles also carry some light with them, and you wouldn't see that on the player in this approach. And we thought of well, it would be cool to just put the video of the player inside the game, so he's part of the game, we do it all together, instead of splitting views and mixing them in external software. So we decided we want to try this out, and we found that others have been trying it out also. Found a good article by Insomnia Games, they've been doing it for their game as well. And we just read through the article, found that, okay, they're using Microsoft Media Foundation library for the video capture, so we don't have to do more than that, hopefully, since they've been using it. So we implemented that. Of course, you have to upload the video of the player to the GPU so you can render with it. And also had to apply some chroma keying to cut away the player from the background. I'll show that later, of course. And of course, you render the player as a simple camera-facing rectangle. Nothing special with that. You just map the video to it. So the headset provides us with the position of the player, and we can safely cut off some parts where we don't expect the player to be in the scene, and get rid of the chroma keying noise in those parts, etc. And you can have other objects there that are not in the way. And yeah, from there we also learn about it's good to be able to adjust player brightness, very simple stuff, so to make it fit in the scene better. So this is just one little example. Here's the camera facing rectangle with already cut off parts, and of course when you apply chroma keying you just get a player. You can see some green light on the player. It's really a lighting problem. That I'm a programmer, so when we do videos, the light is more involved in the setup. So while we were doing this, you know, when you do mixed reality, you really have two cameras. And while we're doing this stuff, like everyone, we had the problem of camera calibration. So you have two cameras, the real world one, physical camera like that one, and it takes the picture of the player. And you have the in-game camera that views the scene from hopefully the same position. And you have to match the two in order to get it to work. So the real world objects match their virtual counterparts. And this process is a huge pain in the ass, and people doing it before us have done weird stuff, like using tape measure to find where the camera is and try to match the stuff. And the process is usually tweaking those. That would be 7 parameters, like the X, Y, Z, offset, the rotation of the camera, 3 angles, and the field of view angle for the camera. And you tweak those stuff. It takes hours to get right, and probably you get better with time, but it's a real pain. And the problem is also that some of those parameters are actually, you should be tweaking the other one. So if you change the FOV, it looks like you're moving the camera forward or backward. And when you get a matching, you get a set of parameters that matches for one scene, then you move, for example, you move the controller backwards, and it doesn't fit because you are changing the wrong parameter. It's really hard to get, and it's a lengthy process. Of course, when you have to do it on a stage floor on some expo, it's also a huge pain, and it's very difficult to get it right. I can't stress that enough. So our solution was to do some kind of semi-automatic calibration, and it worked out really well. And we haven't found anyone else doing it, so it's really. I'd like to report that so people can do it themselves. So what we did after several attempts, we ended up with a process of doing taking samples that match some 2D points on the camera. It's hard to describe by hand waving, so I'm going to show the video soon. And we ended up with 5 points that you look on the screen, and you just match them in the scene with the Vive controller. You take samples, and this process is really fast now. It takes like a minute, and here's how it looks like. So just look at the screen and try to match the controller where this crosshair is, and take a sample there. And I step away, and I do this same 5 points again. So this is a bit fast forward, but in the end, that's all there is. You can see the controller. You can see the controller, the rendered controller matching the one I'm holding in my hand. It's really hard to tell here which one is which. So I got a match, and this was a minute of work, and it was a great improvement. So since this is a big thing for us, I'd like to explain how it works so anyone can do it for themselves. And what we do, you've seen those 2D points, you just place the controller, record the sample, and that's a point in 3D space in the scene. And when you have two points, one closer, one further away, doesn't matter which one is which, you have a ray, and you have 5 rays from 5 sets of 2 points, and we know all rays intersect at the center of the camera, and we get the center of the camera easily. And from those rays we can also get the camera orientation. It's very simple to 3D math to get all the vectors, and that's a orthonormal basis. You get a orientation matrix right away, and it takes some math, but the angles between rays can give you field of view. It's also very easy. So with all that done, we were ready to showcase that for the event we were planning to. And we barely finished in time for the show. There's, of course, the deadline. Minigun controller was there, and when our guys got there, we had problems with the video capture. It didn't work with the Microsoft Foundation library. So some of our guys did the overnight debugging session from Zagreb to Birmingham, and there was nobody there at the show at the time. They were all sleeping. They were at the office debugging and implementing new capture method, which it's supposed to be working because it was used by the OBS software, which we knew they were using. And in the end, it worked out fine. There was some cool videos. I'm sorry. The HTC people were also very enthusiastic about this. As you can see from this, there are lots of gamers trying it out, even big ones. You can also see how it looks like. You can see the girl playing there, and immediately in real time you can see it on the screen also in mixed reality. And also the minigun looks cool. Yeah, lots of people tried it, liked it. Of course, the players liked the virtual reality, the spectators could see it in mixed reality. That was the goal. So once this was finished, we still weren't done with mixed reality for us. We wanted to do to capture some footage for the trailer, and for that we wanted to use the in-game guns instead of the physical minigun that probably very few players are going to touch at some point. So that brought us to the problem of video latency. So you can't avoid latency in this case because you have to capture the frames, not to mention what the camera and the cable introduce some latency as well. So you have to capture them. It takes time. Of course, you have to upload the capture frame to the GPU so you can render with it, and you have to render it. Okay, so this is fairly obvious. In our setup, in the end it was like 60 milliseconds. We did some optimizations there to cut some times, but it's really we couldn't get better than that. And 60 milliseconds doesn't look like much, but it is much. It is a lot. And with the minigun controller, you couldn't see that problem because it was actually physically attached to the player. So there's the connection. And when you use in-game weapons, it looks really bad, like this bad. It looks like I'm chasing the pistol with my hands, and it's really bad. And this wasn't the quality we were aiming for. In the other videos, for example, the HTC video shown at the start, you probably didn't even notice that. Most of these videos were done in post-production. So they would record the game, record the video, and there they can offset the video and eliminate the latency. But since our approach was doing it directly in the game, we don't want to it's a lot of work to do post, of course, and this way it would be all been done by the game, and we had to fix that somehow. And now in retrospect, it looks like an obvious thing to do, but it took us some time to figure out what we wanted to do. And our solution is basically we just delay the weapon where it was, or the controller position where it was when the video was recorded. And yes, that looks good in mixed reality, but the problem was that the player would get the input lag, and that would be a disaster. And in virtual reality, you have to be careful what you do to the player, because he can get sick. And the final solution was, yeah, it looks good in mixed reality, and for the player, for the headset, you just put the gun where it is. So there was some extra code lying around when rendering weapon, just asking, is it in mixed reality? Okay, put it here. If it's not, then put it where it's supposed to be now. And you can't tell the difference. The gun is in the hand where it's supposed to be, and you really don't know where it was 60 milliseconds ago, so you don't care. So that was the solution. Also, one important takeaway, especially in talks with other developers who were doing mixed reality, they were impressed with that. So it's a really simple solution. And when you do that, you just get the gun that's attached to the player's hand. No problem there. Just have to tweak the interval. It always depends on the hardware, so there's an option how to tweak it. Well, with that done, we're practically finished. And of course, we wanted to do some footage with the camera that's moving around the player, because those shots look way better than just having a still camera. You do stuff in front of it. So this lag fix has to be applied to the camera as well. You have to, when you match the virtual camera with the real world one, you have to account for that. And one important thing to note, we also had a problem when we were moving the camera. There would still be some offset. You know, I would hold my gun, and while the camera was moving, the gun would go next to it. So, whoa, what's happening? Why is this happening? And after a lot of debugging, it all looked good. What's happening? And then I found the switch on the camera that says video stabilization on, off, and once I turned it off, it was all good. The last bug was in hardware, so to speak. So this is a very important thing to disable, because video stabilization does things to the image that you really can't account for in software. Well, while we were developing all this, we were also building our equipment along. So for virtual reality, you need a beefy PC, as the best you can get, of course. And when you do mixed reality as well, that's the third view. We also need more power. And we used Vive with this because of the excellent features it provides with room scale tracking and nice holes on the controller that can fit on top of stuff. More on that later. And it's a great thing to have a high-end camera for good quality pictures. A great capture card that's fast and works at high FPS is also crucial. And we recommend doing capture on another PC or some kind of recording equipment, because you don't want to strain the PC running the simulation, the game, and rendering all that stuff. So we used another PC for the capture. And getting the controller on top of a camera in a consistent fashion is a really hard thing to do. We ended up 3D printing an adapter that fits inside the hole of the controller. We found the model online, so it's in the references. And we mounted on top of the hot shoe adapter on top of the camera. we had to use some kind of stabilizer because we turned off the stabilization feature in the camera altogether. So you need that, otherwise you're gonna get really shaky video. So this is how it looks like in our studio, in our office. Lots of green screen, a camera on top of a stabilizer, a controller on top of a camera, and a rubber band, of course, that helps even more to get this thing attached. Here's a little recording session, how it looked like in our office. So it was great having all that on site and doing the videos by ourselves. And in the end, even though we did some stuff to help the setup with the camera calibration thing, and but it was still a mess to set up, because you had to go through the steps in order and not mess anything up, because it wouldn't work for one reason or another. Common problem was mixing up which controller is which. You don't actually know, you just see the serial numbers and stuff. So yeah, most of the time people would get stuck on some problem, and somebody deeply involved with the thing should step in and help. And we wanted to eliminate that, so anyone can do it. Our guys can do it quickly on trade shows, and players can do it at home maybe, and do their own videos. And we ended up doing like a wizard interface inside the game. You just plug in the camera and it tells you what to do at each step. So here's how this looked like in the end. Just select the input, select the frame rate and stuff. You can do green screen calibration here. Not calibration, setup. Until you're satisfied. It's all inside the game. You just enter the in-game menu for where you left off. So we support both the static camera without the extra controller, or you can have the camera attached to a controller, and that allows you to get that footage of where the camera is moving. Of course, the camera calibration takes about a minute, so I'm gonna skip that. Since we talked about that already, you get to see the results, but the wizard is still active, and you could even do some manual configuration if you want to, but I highly don't recommend that. Of course, the player setup, the brightness, it's all done in the level, so you can just adjust how you like it. The controller delay, or fixing the video latency, as I talked about earlier, you just adjust the numbers until you're happy with the result. And one cool feature we have is you can rotate the play space, so you can get a nice view of the action you like without doing the room setup again. And that's it. As you can see, this lasts like 2 to 3 minutes altogether. It's not a big hassle like before. So that was the final step we took. There were some cool videos online, and there were some weird moments. at the trade show. This was our setup in Zagreb on our local consumer show, Reboot, Infogamer, yeah. Here's another feature that I didn't talk about, but I can mention it. You can even have a different FOV for the spectator camera and the real world camera, so you can make the player smaller so it doesn't take up the entire scene, and features like that. Some weird moments not actually related to mixed reality for the player. So this girl is trying virtual reality for the first time, and she kind of got very immersed and kind of freaked out. She's actually a wife of one of our guys. So yeah, it was fun doing it, and here are some of the reference of the stuff I talked about, and a last link you can find the article I wrote about this topic. So feel free to check it out if you're interested in this area. So thank you for your patience, and we have time for questions.
Any questions? Okay.
Hi. You mentioned aligning lighting to the of the player, the film player, and the game world. Did you find any solution for that? Maybe for game shows, you had some special lighting to go together with the scene?
Well, I'm not an expert in this field, really, but people who know about studio equipment, video recording, they know how to light things so they look good. If I remember, if it is good to have some kind of light source on the player, so the green doesn't leak too much on it, because when the light bounces off the green screen and back to the player, and also clothing is very important. Of course, you avoid green stuff, but also we found out that some gray stuff works best with that. Really, not an expert, just what I've seen in the recording sessions.
Okay, so it's basically just static lighting and you don't touch it.
Yeah, of course.
Okay, thanks.
Thank you. Anyone more? Okay, so thank you very much, Goran.
Thank you.